Welcome back, my friends. We're looking at the review for the second quiz. I know there's not a lot of time between quizzes here. That's why I decided to go ahead and do a work-through video of all the questions on this one. Number one says Q is between P and R. First thing you're doing if you want to be successful is drawing out that situation. So I have P, I have R. It says Q is between. It does not say in the middle. It just says between. So it says Q is between P and R. Okay, so I got Q. I fit this description, got it. S is between Q and R. So Q is between P and R. S is between Q and R. So S is somewhere over here. Maybe the middle, maybe not, I don't know. R is between Q and T. So R is between Q and T, so T's got to be somewhere over here to get R between Q and T. All right, got that. It says PT, so the entire thing is 34. QR, so this section is 8. And then they tell us a little sequence here. PQ, SR, and SQ are all the same size. What is the length of RT? So the end goal is RT. I'll call it X. That's what we're looking for. All right, so let's go through. What do we know? Well, we know that these three sections are the same size. Well, if these two sections add up to 8, they have to be 4 and 4, which means this section is also 4. So we know that from P to R, this entire section is 8 plus 4, or 12. And the rest of it we called X. So we know that PR plus RT has to equal PT. Right? P to R plus R to T has to equal P to T. So P to R is 12 plus X, and it has to equal the whole thing, 34. So X has to equal 22, which is the question, or which is the answer to the question. Find the distance to the nearest thousandths between the midpoints of ML and JK. So it's the distance between the midpoints. They did not give us the midpoints, so we got to get those midpoints. So we're going to get the midpoint of ML. So here's ML. I'm going to stack those. I have 4, 3, and 1, -1. Midpoint means to add and divide by 2. That would be 5, 2. Divide by 2, and that's going to be 5/2, 1. So there's the first midpoint. That's the midpoint of ML. The second midpoint we need is the midpoint of JK. So I'm going to change colors here, work in purple. I need the midpoint of JK. I'm going to stack them. And I'm going to get the midpoint of JK. So that's going to be 4, -3, and -1, -2. And I'm going to add and divide by 2. So when I add, I get 3. And when I add, I get -5. I'm going to divide by 2. And that's going to be 3/2 and -5/2. All right, so we've added and divided by 2. I've got the midpoints, but what's the question? It's the distance between the midpoints. So the next step is to use the 2 midpoints to get a distance. If you need a calculator, get it. Remember to get distance, you subtract. I need to know how far apart 5/2 and 3/2 are. If you want to think of it as decimals, that might make it easier. 5/2 is 2.5. 3/2 is 1.5. How far is it from 2.5 to 1.5? It is 1, and we square it. Then we do the same thing to the y's. How far is it from 1 to -5/2? Or if you want to, if it helps, -2.5. How far is it from 1 to -2.5? And that is 3.5. And we square it. So it's the square root of 1 squared plus 3.5 squared. I'm going to type that in my calculator. And that is the square root of 53/2. But they, look at the answer choices. They're all rounded. So we should probably round it. And that rounds to 3.6 3.640. And that's our answer here, 3.640. So I had to get the distance between the midpoints. To do that, I had to get the midpoints first, and then I had to apply distance to it. Because they were fractions, it was a little bit easier for me to think of them as decimals this time. And so I thought of the decimal version to figure out how far apart they are. Answer to each of the following is sometimes, always, or never true. Even though you can't provide them here, you should be thinking of examples and counterexamples. Okay, well, we'll do that. And I already have the answers written in here, but we'll talk about them. Complementary angles are acute. So here is a Here's a right angle. And so complementary angles have to add up to 90. So if they have to add up to 90, is there any way for them to be 90? Can one complementary angle be 90? No. There'd be no room left over for the second one. So both of these angles have to be less than 90 for sure. I mean, so that's going to be always. You can't be 90 or bigger and also add up to 90. You can't do it. Supplementary angles are adjacent. So remember, supplementary angles are two angles that add up to 180. So could I have angles 1 and 2 form a line? Yep. So it can happen. Or could I have two angles like a 40-degree angle and a 140-degree angle? These are not adjacent. Remember, adjacent means next to or touching. So can it happen? Yes. Does it have to happen? No. So that's where sometimes comes in. That's why the answer was sometimes. So I'll write it over here so it's easier to see, but it's sometimes. Vertical angles are adjacent, never. Those are competing definitions. Remember that vertical angles are angles that form by opposite rays, meaning that the rays form a straight line. That means they're always across from each other, facing exactly the opposite direction. They can never be next to each other if they're doing that. Linear pairs are obtuse. This implies both angles are obtuse, to be clear. So if I have a linear pair, remember a linear pair is two angles that form a line. Well, they could be, here's one obtuse, one acute, or I could have two right angles. Couldn't they both be 90? Or if I go this way, I have an obtuse and an acute, just the opposite ones. But like at any point, are they both bigger than 90? Nope. They have to add up to 180. So if one of them's bigger than 90, the other one has to be less than 90 because 90 plus 90 is the cutoff. So linear pairs are obtuse. That is never. I'm going to put never over here so it's easier to see, but that's never. Two obtuse angles are vertical. Well, can I draw opposite rays where I have obtuse angles that are vertical? Absolutely. But in the same picture, I have vertical angles that are... Oh, actually, that doesn't prove it wrong. So those are obtuse angles that are vertical. The counter example would be, can I draw two obtuse angles that are not vertical? So could I draw an obtuse angle here and then another obtuse angle there? Are those obtuse? Yeah. Make it a little more clear. Can I draw two obtuse angles? Boom. Are they vertical? No. So that's definitely sometimes. Supplementary angles are linear pairs. Well, we already actually did a similar one, or I guess that supplementary angles are adjacent, real close to the same idea. But can supplementary angles be a linear pair? Yes. Here's angle 1 and 2. They form a line, so we know that that's 180. But could they be out here? Could supplementary angles be like a 90 and a 90 and not be linear pairs? Yes. Linear pairs have to be adjacent. So really, these two questions are the same question. Complementary angles are vertical and congruent. So complementary angles are two angles that add up to 90. So in other words, can two angles add up to 90 and be vertical? Can two angles add up to 90 and be congruent? And the answer is yes, they can. So if I were to draw an intersection that uses perpendicular lines, 90 and 90 are these. Wait a second. They have to be complementary. Bad example. They have to add up to 90, not be 90. So I just made a mistake that some of you guys will make. But could I have two 45-degree angles? Are those complementary? Do they add up to 90? Yes. Are they vertical? Yes. Are they congruent? Yes. Can I draw complementary angles that this is not true? Yeah. Could I have an angle over here that's 10 and an angle here that's 80? They're not vertical. They're not congruent. They're none of those things. But do they add up to 90? Yes. So the answer is there sometimes. I'm going to go through and circle all these answers just so you can see it. Woo! Challenge question. Love it. Use the given information to solve for x, solve for y, solve for the measure of SRA, and determine if RD bisects pre. Okay. So let's take a look here. PRY. We got to go through every detail, make sure we get it in the right spot. Angle PRY is this little one, right? PRY is that angle. And that's 5x minus 3. Then we have YRD. YRD, that's this angle. And that clocks in at 3y minus 8. PRI. Where's P? PRI, that's all of this. That's this entire thing. Clocks in at 13x plus 23. And then we got MRA. MRA, that's this guy. And that is 10x. So one thing I'm noticing while I'm doing this, I don't have any vertical angles yet. I don't have any equal angles yet. But I do know, yeah, so I don't have anything really to work with yet. But I'm looking for that as I go. And then VRU, over here, VRU, that's this one, clocking in at 42. Okay, now I do have a situation that's a little bit helpful. If that one's 42, I'm going to go and mark this one 42. These are vertical angles. So those are going to be the same size. And RY is an angle bisector. Ooh, let me go back over there. RY, right here, is an angle bisector for PRD. So if it bisects PRD, that means this little one and this little one are going to be equal. Okay. So there's a lot going on here. You got to come up with a plan. So a few things you need to remember is a full line is going to clock in at 180 degrees. We have really one good way to start this. I want you to look at it for a second. I'm going to use a new color. I don't know. Let's see. Boom. That one looks fun. I only see one way to start this, and it's pretty hard to see. All of this is a line, right? It's this straight line right here. And we know from here to here is 13x, it's 13x plus 23. I'm going to put it up here. That is 13x plus 23. We know to this part it's 42, so I need to add 42 to that. And then to finish the line, it's another 10x. The reason I picked that equation is that's the only equation here that has one letter. I know that these two angles are equal, but that's two letters. So we couldn't solve for anything there. So that's really hard to see. I don't want to erase everything right now, but I'll erase it at the end just to show you. But we have an entire line's worth of angles, and it uses x, a constant, and an x. That's only the letter x. We know that all of those have to add up to 180. So we can actually solve for x now. We have 23x. We have 23 and 42 would be 65 equals 180. So 23x equals 115. And that should be 5, but I don't want to be wrong. So 115 divided by 23 is in fact 5. So I know that, oh, it's right there. So I know that x equals 5. Once I know x, now I can go here and use the fact that these two angles are equal. If this is an angle bisector, then these two are equal halves. So I know that 5x minus 3 equals 3y minus 8. But we just said x equals 5. So I know that 5 times 5 minus 3 equals 3y minus 8. So 15 minus 3, I know 12 equals 3y minus 8. So x equals 5, right? Yeah. 5 times 5. What did I mess up? That doesn't feel right. Oh, I see. See, mistakes happen all the time, guys. I messed up. It is, here we have 5 times 25. 25 minus 3 is 22. There we go. So this equals 22. That's where I messed up. Add 8, and you get 30 equals 3y. So y equals 10. And that's another one of our answers. Okay. So if x equals 5, we know that this angle comes in at 22. We know that this angle comes in at 22. Plug in 5 there, 13x, 13 times 5, plus 23, right? We know this is 88. So if all of this is 88, how do I get this part? Well, I would do 88. I know my work is getting really messy now, but I would do 88, and I would do minus 22, minus 22. So 88 minus 22 minus 22. So those are actually equal parts. It's going to be 44. So I know that this section's 44, and that's angle SRA. No, it's not. So this would go here. So we know this is 44. We know that these combined are 44, so this is going to be 44. Lots of vertical angles going on. And then the last one, 10x, 10 times 5. We would know that these are 50 and 50. So we got everything now. The question is, does RD, man, I need the whole picture again. But is RD an angle bisector? The answer is yes. It was 44 and 44, right? 22 plus 22 is 44. That's how we knew this was 44 and 44. Because vertical angle is 44. Vertical angle is 44. So the answer is yes. That's a really tough question. No wonder it's a challenge question. All right, we've talked about these in class. Twice an angle supplement. Real quick, x is the angle. 90 minus x is the angle's complement. 180 minus x is the angle supplement. These are things we must know. So keeping that in mind, twice an angle supplement would be twice the supplement that we just wrote. That's twice an angle supplement. Is always an equal sign. And then 30 degrees less than, all that. So 30 degrees less than means minus 30, something minus 30. If I'm going to be 30 degrees less than something. 5.5. So what is 5.5? 5.5 or 11 halves. I'm going to write it as the fraction. 5.5, 11 halves. Times its complement. Its complement is 90 minus x. So this is the equation I just translated. Twice the supplement, I got it. 30 less than, I got it. 5.5 the complement, 5.5 the angle's complement. I got it, I got it, I got it. This is your starting equation. So we have a few options we could do here. I'm going to go ahead and do my distributions. So I'm going to do 360 minus 2x. If I distribute that, that would be, I'm going to type it in just to make sure I don't mess up. But it should be like 49, I don't know. Okay. 11 halves times 90 is 495. And then minus 11 halves x. Remember, we're distributing here. And then we have a minus 30 that's not in those parentheses. Fractions can be difficult to deal with for some people. Might be easiest to go ahead and get rid of the fraction. So I'm going to do that. In order to get rid of the fractions, I need to multiply everything by 2. This is a 2 in the denominator. So if I multiply everything by 2, I get 720 minus 4x. Just in case, I don't want to get it wrong, equals 990 minus 11x minus 60. Now I don't have any fractions. My next job is to combine like terms. 720 minus 4x equals, that'd be 930 minus 11x. I want to get my x's on the same side, so if I add 11x, I would have 7x. Subtract the 720, so 930 minus 720 is 210. So x equals 30. Whew. Well, if x is 30, that's the angle. The complement would be 60 because the complement is the number we need to get to 90. So the complement would equal 90 minus 30, and the supplement would equal 180 minus 30. So x is the angle, and that's how you get the complement and the supplement. That's another hard question. We're loading you up. Angle ABC is 3x plus 2. Angle CBD is 5x minus 28. It says BC is a bisector for angle ABD. That means that these two parts are equal. So we can take 3x plus 2 and set it equal to 5x minus 28. We know that those two small angles are equal to each other. So we get the x's on the same side, 2x, move the 28 over, that would be 30. So x equals 15. Find the measure of angle ABD. Well, they want the measure of the whole thing. So 3 times 15 plus 2 would be 47. So we know that this is 47. That means this one has to also be 47. But this is one way I could check my work. I'm going to go ahead and plug it in there as well. 5 times 15 minus 28. Is that also 47? Yeah, 75 minus 28. It's going to be 47. So we just confirmed, we solved it correctly. So they're both 47. 47 times 2, the whole thing would be 94. Angle ABD, that's the whole thing, is 10x minus 3. Oops. Angle ABC, that's this part, is 2x plus 11. Angle CBD is 7x plus 1. So in this situation, we don't know anything is equal, but we know that if we take the measure of angle ABC and we add it to the measure of angle CBD, that it's going to equal the measure of angle ABD. We know that small plus small equals total. So we know that 2x plus 11 plus 7x plus 1 has to equal 10x minus 3. So 9x plus 12 has to equal 10x minus 3. So x has to equal 15. So we plug that in. This 15 times 2, this would be 30. This would be 41. 7 times 15 would be 70 plus 35 would be 105. That'd be 106. And the actual question is ABD. Well, ABD would be the sum of 41 and 106. Or you could plug that in here. That'd be 150 minus 3. That's 147 if you plug in your x. And that's the last question. So there's definitely some tough ones. As I'm looking through this, the biggest issues are going to be number 5. For sure, number 4. Yeah, 1 and 2 as well. This was a hard review from top to bottom, I would say. A lot of good, you had to know your stuff. So I don't want to say it was like super hard, but you had to know your stuff. You had to know what you were doing. Hopefully that helped.